Michael Phelps's record-breaking haul of 8 Olympic medals in Beijing was a powerhouse display of swimming prowess. But even an athlete like Phelps would sink quickly to the bottom of a pool if he began a race with his arms wrapped around his legs, curled in a tight ball. The body sinks in this position, as opposed to a body that is stretched out and laid flat. This is because of buoyancy. Buoyancy is one area of fluid mechanics, the study of how fluids move and the forces that act upon them. Why does one shape float and another sink? Stretching the body flat in the water causes the water to push against a larger surface area. And if the total area of the body that makes contact with the water is large enough, the body floats. Conversely, a body curled up into a ball has less water pushing against it and therefore sinks. Buoyancy is the loss in weight an object appears to experience when underwater, compared to its weight on the ground. The object has to make room for its own volume by pushing aside an equal volume of liquid. The object is exerting a downward force on the water, and the water exerts an upward force on the body, equal to the weight of the liquid being displaced by the body. This is Archimedes' principle of displacement. Swimming is dramatically affected by water resistance. Fluid resistance consists of 2 components, drag and lift. Drag occurs because as a swimmer moves through the water, the body's velocity is opposed by the drag force. This again illustrates the action-reaction principle. There are 3 types of drag force: surface drag, form drag, and wave drag. Surface drag is where the surface of the object, influenced by its texture and shape, interacts with the water. Surface drag is created by the friction between the surface and the fluid. Wearing loose clothing can create surface drag. Form drag creates a pressure differential from the front of the body to the rear. And wave drag is a reaction force to waves generated as the body moves through an area where 2 fluids meet, in this case, air and water. In scientific terms, air and water are both known as fluids. This is why athletes like swimmers tend to wear form-fitting clothing. They are trying to streamline the body shape and minimize the effects of drag. The other component of fluid resistance is lift. The lift force acts in a perpendicular direction to the drag force. It happens when the object is not shaped symmetrically, or if spinning, when it is influenced by the Magnus effect. The lack of symmetry causes lift to occur because the water on one side of the body moves faster than the water on the other side, thus creating a pressure differential. Swimmers can utilize the lift principle by orientating their hands in different positions relative to the water and thereby enhance their overall speed. This is the motion at work in the breaststroke style. In swimming, where hundredths of a second make all the difference, fluid mechanics are very influential in driving advancements in techniques, training, and equipment.